Day, everyone. I am Crystal Tanyan, BEd 2A, and I am going to discuss about my topic, which is supermassive black holes and galactic centers. So first, let us now get the meaning of supermassive black hole. So it is a type of black hole that is millions to billions of times more massive than our sun. These enigmatic cosmic objects are typically found at the centers of galaxies, including our very own Milky Way. So, sa ija pa naman nga word nga supermassive, obviously kining supermassive black hole ang pinaka-massive, kung moingon tang massive, pinakadako or pinakabugat sa tanan, which happen nga mas massive pa ni siya kaysa sa ato sa sun. O imagine that, unsa siya ka dako. Kini supermassive black hole is makita din ni siya sa tunga or sa center jud sa galaxy, including na diha ang atong very own Milky Way. So here's a detailed explanation of supermassive black holes. So first, formation. The exact process of supermassive black hole formation is still a topic of ongoing research, but several theories suggest that they could form through the gradual accretion of mass over a long period. Alternatively, they might have formed through the collapse of massive gas clouds in the early universe. So, ang formation ining supermassive black hole, wa jay mga researcher nga nakakuha og unsa jay exact process nganong na-form ning supermassive black hole kay until now still a topic of ongoing research gyapon ni siya. Pero naay mga several nga theories ni suggest nga ang na-form kuno ning supermassive black hole sa pag-collapse sa mga massive pod nga gas clouds sa early universe, which is ingadto pa yung una. So, I have here a short video for us to lightly understand about the supermassive black hole and galactic centers.
There's a supermassive black hole at the center of every large galaxy in the universe. Why are there black holes at the center of galaxies is one of the big questions in astrophysics and cosmology. Astronomers can detect them by observing the effect that central supermassive black holes have on nearby stars and gas. But are these giant black holes important in the formation of galaxies? Or do they just form in the meantime and then migrate to the center? First of all, one possible scenario for the formation of supermassive black holes starts with a chain reaction of collisions of stars in star clusters. The merging causes a buildup of very massive stars, which eventually collapse to form intermediate mass black holes, which astronomers estimate to have between 100 and 1,000 times the mass of the Sun. Such compact regions then sink to the center of the galaxy, where the intermediate mass black holes collide and merge to create a supermassive black hole. Now, supermassive black holes can contain hundreds of millions of times the mass of the Sun. Such black holes are very connected to their home galaxies, and scientists have evidence that the mass of a supermassive black hole has a direct correlation to the galaxy they reside. Typically, a huge amount of galactic matter falls into a central supermassive black hole. Obviously, the black hole can't consume such a vast quantity all at once, so an accretion disk forms, heats up, and glows brightly as an active galactic nucleus, or AGN. But this feeding process is not constant, and it all depends on how much matter is available for the black hole to consume. And then, if the nearby matter is clumpy and irregular, we can see the AGN turning off and on, or flickering. Keep in mind, however, that the Milky Way's central supermassive black hole is not considered an AGN because it's dormant and not feeding on anything. Another theory as to why these supermassive black holes end up in the center of galaxies is that a dark matter halo that theoretically surrounds every galaxy helps to focus and concentrate material during galactic formations. Scientists theorize this material coalesces into the central supermassive black hole, while the rest becomes the stars of the galaxy. However, there's also an opposite theory that suggests black holes formed first and gravitationally clump the rest of the galaxy around it. The bottom line is that all large galaxies have a central supermassive black hole, and their evolution and structure are closely tied to the scale of their central black hole.
Okay, so obviously kining supermassive black hole di ay mao ning controller dahil sa stars sadya ang ni-govern sa mga behavior sa mga object didto sa ibabaw. So, sa size and mass, supermassive black holes are characterized by their immense size and mass. So, immense size, grabe jud agdyang ka dako no. They can have diameters ranging from a few million to billions of kilometers and possess mass equivalent to millions or even billions of times that our sun. So, grabe jud din siya ka bug-aton or kadako kay imagine millions or even billions of times that our sun ug unsa kadako ang sun dako pa jining supermassive black hole unsa ni siya kadako. So let's talk about the gravity's grip of supermassive black hole. So like all black holes, supermassive black holes have an horizon which is a boundary beyond which nothing. So ang iyang horizon wa jud boundary beyond nothing, not even light can escape. This creates a region of intense gravity that traps anything that ventures too close. So, naani jay ijang region palibot ni intense jud adyo a gravity nga tanan nga moduol niya nga ma-close, matrap jud didto mo na siya nga dako jud siya kaadyo mag-ana mo kadako. Galactic centers. Supermassive black holes are typically located at the center of galaxies. So, motong ganina nga na-locate ni siya sa center sa galaxy. They play a vital role in governing the motion and behavior of stars and objects within their galaxies. So nagplay ni siya og vital role nga importante nga role nga siya ni govern sa motion o sa behavior sa stars sa objects sa ibabaw nga siya nag-control. Significance in galactic centers. So the presence of a supermassive black hole at the center of a galaxy has several significant implications. So nadyo mga several significant application nganing kuan supermassive black hole sa galaxy, which is galactic dynamics. So supermassive black holes significantly influence the dynamic of their host galaxies. So sa pagka dynamics sa host galaxy na ani siya influence. They act as a gravitational anchor helping to bind the galaxy together. Siya murag nag-act nga gravitational anchor nga motabang para mabind ang example duha ka galaxy together matampo. The orbits of stars and other celestial objects near the galactic center are influenced by the black hole's immense gravity. So imagine ang celestial object ug mga orbits of stars ang naka-influence ingan ani siya kay unsa day ka grabe ang gravity sa supermassive black hole. Sadya hinungdan nganong kuan sadya naka-influence sa mga orbits sa stars ug sa mga celestial object sa galactic center. Energy sources. As matter falls into a supermassive black hole, it forms an accretion disk, where intense friction and gravitational forces generate tremendous energy. So, tungod kay grabe ijang energy gravity ngadto, nagkuan pud siya og intense friction o nga naka-generate sa grabe nga tremendous energy. This can lead to the emission of high energy radiation kay grabe man ang gijang friction o gijang gravitational forces na nag-lead po ni siya nga sa pag-emit sa high energy radiation including na dira X-rays and the gamma rays. And also active nuclei, galactic nuclei such as quasars and Seyfert galaxies are powered by the energy released from supermassive black holes. So gikan pud to sila sa energy nga na-release sa supermassive black holes kaning quasars and Seyfert galaxies. Sa regulating star formation, so sa pag-regulate sa star formation, naka-influence po din ang supermassive black hole. So imagine that grabe ang influence sa supermassive black hole sa dito sa galaxies. The energy and radiation emitted by the black hole can heat and disperse the surrounding gas, influencing the birth of new stars. So ang kana kunong energy nga na-emit sa supermassive black hole ug kanang init mo kuno na jay na influence nganong naay new stars formation. This help maintain a balance between the formation and destruction of stars. So mo na siya ang grabe sa ka-energy sa supermassive black hole nakatabang sa pag-maintain na o pag-balance sa formation sa og sa destruction sa mga stars. Galactic evolution. So, naka-influence po ni siya sa galactic evolution. The growth and gravity of supermassive black holes are linked to the evolution of their host galaxies. Interaction between the black hole and the galaxy can shape its structure, overall development over time. So, usa po ning supermassive black hole mergers. Magmuntang merge, magtampo. Occasionally, supermassive black hole is in close proximity can merge, releasing a gravitational waves, which have been detected by gravitational wave observatories like LIGO and Virgo. These mergers are thought to be crucial events in life of the galaxies. So, understanding the nature and behavior of supermassive black hole is a key area of astrophysical research. So, mo ni jay key area sa astrophysical research. Ug mo astrophysical research mo ni ag study sa universe. They are not only fascinating objects in their own right, but also critical to unraveling the complex interplay between black holes, galaxies, and the wider universe. Okay, that's all. Thank you for listening and watching.